Hello everyone, now we are gonna start our next chapter and the name of the chapter is hashing. Hashing is a very important concept in computer science, and using the concept of hashing there are a lot of real world applications based on this concept. So understanding the concept of hashing, and from the hashing we derive various data structures. So in this chapter, in this whole hashing chapter, what we will study is that we will study the data structures and the algorithms which we derived from the concept of hashing, and we will study a little bit about how hashing works, but we will not go deeply into the internal working of hashing, because the working of hashing is totally dependent on what algorithm you are using in, right? And Java uses its own algorithm, C++ language uses its own algorithm of hashing. So the algorithm may differ, but the overall concept of hashing is same. So let us start with our chapter. So the word hashing, what is the meaning of it? Let's say that I am giving you a parameter, input parameter with numbers. Let's say I am giving you my input as numbers, or I am giving you my input as characters. Let's say I am giving you name. So I have given you one form of data. Converting one form of data into another form, this whole process is known as hashing, right? So I have given you input data and you are converting it into some random values, some random data. Let's say I am converting into a combination of numbers and characters, 93 a at the date hashtag something. I am converting your given input into another data form. This whole process is known as hashing, and the function by which I am converting it, this is known as hash function. So the function which I am using to convert the whole given input parameter, one data form, into another data form, that is known as hash function. Okay, now this whole process of converting one data form into another data type into another data form, this is known as hashing, right? This is known as hashing, and we use hashing in real world applications. Like, let's say you are creating an account in Google. So when you create account in Google, it will ask password, right? When you are creating a Gmail account, the Google will ask you password. So let's say I'm giving my password as Jabir and 1234, this is my password. So what Google will do is that it will not directly store the same password as Jabir1234 into the database. So what Google will do is that it will convert this data form into another data type using some algorithms. We have different hashing algorithms. Java will use some different hashing algorithms. Google might use some algorithms based on salting and all those kind of things. We have in hashing, we have different algorithms. C++ use their own algorithms, right? The algorithm may differ, but the process will remain the same. So what will Google will do is that it will take your password, it will perform some algorithms, and it will change the data form. So it will perform the hashing process, and after that it will change the data form. The password you have stored, Jabir1234, will not be in the same form. It will get changed, and the changed form can be anything. It can be characters, it can be a combination of numbers, characters and letters, whatever it might be. So after hashing, let's say that my overall password has become something like that, 93 at the rate hashtag at the rate colon, something like that. So this hashed form will get stored in your database. Now you might ask why Google is doing that, and our company, if you go to imaginaryhub.in and if you log in, then we are using the same process. We don't directly store your passwords directly, right? We don't, let's say you are giving some random name as your password, so we don't directly store that in our database. What we'll do is that we will also perform some hashing algorithms. We use salting algorithms there. So in hashing, salt algorithms is one of the part of it. So we use salting process there. So why we are using it? Why we are converting one data form into another data form? Because let's say that Google is not doing this whole process. For example, let us assume that Google or all these big companies is not doing this process. So what will happen? Let's say they are directly storing your password into their database as it is. So you are giving Jabir1234, this password Jabir1234 is directly getting stored in the database. Now let us consider that scenario that the whole database got hacked. Now the hacker can access your usernames, and if we haven't performed the hashing algorithms, then he can directly access your password. And for example, as a user, let's say I have given the same password to Google, I have given the same password to Instagram, I have given the same password to Meta, Facebook, and all Gmail, all those kind of different platforms. I have given the same password. Now if he can get the password, then he can access all my different accounts. That is why we use, to prevent this accessing, to prevent the data breach of a particular user, we use the concept of hashing. Now for instance, let us assume that the database is hacked and we have performed hashing. So your password is not in the direct form, the password which you have entered, it is not in the same form, it is in different form of combination and letters and characters. So when the database got leaked, in the database, let's say I am having for a collection, I am having for a single document, for a single user, I am having username and password. So we are not performing any operations, any algorithms, we are not performing any hashing algorithms on username. So username, a hacker can easily access. Let's say my username is Jabir Hussain, a hacker can directly access Jabir Hussain username. But when he goes to password, my password will be this. But my actual password, if I want to access my account, I need, in the password session, I need to write Jabir1234, Jabir1234. But in the hash form, the hacker will get this form. Hacker will get 93 at the hashtag and something, a long form of string. This will get, the hacker will get this, and from this to this, a hacker can never go. Because to convert from a hashed form to the original password, to go to perform some reverse engineering in this algorithm is very tough. Because in the backend, I don't want to go into the deep of the backend, but what will happen is that all these passwords, all this encryption also, this is based on an algorithm, this is based on a concept called as RSA encryption. So in RSA encryption, what we will do is that we will take a long prime numbers, we will take two long prime numbers, multiply them, and you will get again a long prime number, right? So that prime number will get converted into letters, and that letters is the hash form. So if you want to go backtrack to the original password, if you wanna do reverse engineering here, then it is very tough. A hacker can never do that. The probability of doing it at least very low. So this is why we use the concept of hashing. So this is the one practical example of hashing, storing password. Now I have talked about RSA encryption, so I want to talk about a little about RSA encryption. Let's say that you are using WhatsApp. So you can see that in the WhatsApp it will show encrypted. Your chat is end-to-end encrypted. Let's say that I am, as a user, Jabir is chatting with another person. Let's say that I am chatting with another person X. So when I chat, let's say that I have sent hey to this person. So what will happen is that this is end-to-end encrypted. This is end-to-end encrypted. So what is the meaning of end-to-end encrypted is that, let's say I am sending hi. Now there is a hacker and he wanna hack the message which I have sent. And for example, for instance, let us assume that he hacked my message. So when he hacked this whole platform, this whole cloud, what he will see is that he will not see hi. He will see some random numbers like this. Like he will see a long prime number, or he will see a long list of string. So what RSA encryption means is that whatever the message I am sending, first of all it will get converted into a prime number, and again this prime number will get multiplied with another prime number, and this prime number, let's say I am getting resultant prime number as something y. So this y will go to my user, my x is on the other end, right? So before going to x, this y will get converted, again this y will get divided by prime into prime, the same prime which our engine has used. After that my message will get converted to hi, and now my hi will go to my x, right? So let's say that a hacker is coming in, and hacker is coming in this platform, and here he wanna see the two bodies chat. So if he tries, let's say he got successful, so if he tries, then he will get a long list of strings, because the same message which I have send it, it is not in the same form. The form will get changed using the same concept. So this is a form, this is the concept of hashing. So what is the meaning of hashing? The meaning of hashing is that converting one data form into another data type into another data form. This process is known as hashing, and this can be done using a function called as hash function. So I hope you have understood what is the meaning of hashing. Now in this, let me remove the ink here. So in this chapter, what we are gonna do is, we are not go deep dive into what is hashing, how it will work. We are not gonna talk about it. Using the concept of hashing, in Java, we have derived some data structures. We are studying data structures and algorithms, right? So in Java, we have derived some data structures, and we will study about the data structures and the algorithms involved in it. We will not go deep dive into, we are not gonna deep dive into what is hashing, the internal working. We will talk about it, but we will not go into deeper of it. Okay, we will only talk about what is required for us. So what is required for us? We need to study data structures and algorithms. So whatever the data structures that we are deriving from hashing concept, we will study it. So we using the concept of hashing, we derive two data structures. Which is a map and a set. So we derive these two data structures from using the concept of hashing. Now again, a map is again divided into three types, that is hash map, linked map, and tree map. Similarly, a set is again divided into three types, that is hash set, a linked set, and tree set. So we will talk about each one of these data structures. What are these data structures, how we use it, how this data structure uses the concept of hashing. We will talk about it in detail. So in this, we will study about what is hash map, linked map, tree map, hash set, linked set, tree set. We will study about each one of them in detail, and after studying this 6 different data structures, basically different data structures, we will do the problem based on it. So I hope you have understood what we are gonna do, and I am thinking to divide this chapter into 2 parts, or if needed, I will divide it into hashing concept into 3 chapters, 3 different videos, and based on, I wanna cover each and every nuance, each and every question of it. So this is the overall idea, this is the overall working of, this is my idea of explanation of hashing. Now let us talk about our first data structure, which is hash map. So talking about hash map, a hash map is one of the data structures which is used to store data in tabular format. To store data in table format, we use hash map. Okay, and whatever the data we are storing in the form of key value pair. Now if you are coming from web development field, if you have studied databases, in database we have a framework called as Mongoose. So Mongoose is a framework of MongoDB. So in MongoDB we create in MongoDB what we do is that we create a collection. Collection is nothing but, you can imagine a collection as a file, and in file we store different documents, right? So in each and every document we store data. In each and every document, you can consider it as a document as a single user. So we store the user's data in the form of key value pair, right? So we store their data, a user's data, in the form of key value pair. Now why I'm telling it? Now why I'm talking about MongoDB? Because if you understand the concept of hash map, then when you go to web development, when you go to like overall developmental field, in there you will study databases. In databases we will study SQL, MySQL, MongoDB, right? In that technologies we use the same concept. So if you are clear with what we are learning here, then it will become very clear to you. At that point it will become very easy to understand. Okay, now let us talk about hash map. So a hash map is a data type, is one of the data structures which is used to store the data in the form of table, and this storing process will happen in key value pair. Now let us take a practical example of it. So if you talk about the practical example of it, the best example I can think of right now is menu. So when you see our college menu, our canteen menu, you can see that first of all I will have whatever the dishes the restaurant is having, and on the right side I will have their prices. So let's say I am having biryani, and biryani price is let's say 200, and burger price is 150, pizza price is 200, and water price is 200. After that some pizza, let's say I have taken Pepsi, so Pepsi price is let's say 150. So can you see that I am storing on the left side, these are keys, and I am storing the values, the pricing on the left side and on the right side, and that is known as values. So here if I want to access a value item which is having price as 150, so if I give price as 150, if I give burger, then its price will be 150. See pizza, its price will be 200. Like this I can store the data in tabular format. If you see that I am storing the data in tabular format, and this storing is happening in the form of key value pair. So this is how in the hash map we store data. Now another example would be countries. So if I want to create a data structure in which on the left side I am storing country's name, on the right side I am storing population. So what I will do is that I will create a hash map, and I will give some name to hash map. After that, here the key will be my country name, let's say India. After that its population, so my value will be their country's population, let's say 150. After China population, let's say 200. After US population, let's say 80, and UK is 50. Like this, to store my data in tabular format in key value form, I use the concept of hash map. Now one more thing is you need to remember in the old session of hash map is that hash map is a very efficient data structure. The operations to perform insertion, deletion, and let's say that if you want to get any value, if you want to get any key or value in my hash map, these three operations will take constant time. That is why hash map is a very efficient data structure. Now you might see that in the menu, if I want to search particular item, then I will go from top to down. So I will go from top to down. I will see each and every item, I will go through. So what I am doing is I am performing linear search. In that I am performing linear search. So you might say that if I perform linear search, then the time complexity will be big of n. But when it comes to hash map, all you have to do is that if you want to get a particular item, just pass its key, then you will get that item. Let's say that what I will do is that I want to get an item called as Pepsi. So what I will do is that I will use get function. Here I will pass my Pepsi, and this Pepsi will give me this item, directly this, right? So how a particular element is created in my hash map. So to visualize how an element is being created in my hash map, I will show you a demonstration. So let us consider that this is my hash map. So what will happen is that let's say I am creating India, and the key is India, the value is 150. So what will happen is that internally this storing, this creation will happen in the form of node. So my hash map will create a node called as India. In that it will store the population 150. It will create a node like this. Now if I want to add a new node, then what will happen is that it will create, now I am creating China. So if I want to create China, then a new node will get formed into my hash map. So in the hash map, China will come here. After 200 will be here. Like this, a new node will get created. After for US, similarly this thing will happen. Now for UK, similar thing, the same thing will happen. Like this, different nodes in my hash map will get created. So this is not storing in the form of linear form. When you see an array, when we are performing linear search in an array, what is happening there? I am iterating through each and every element, okay? And this is how I am performing searching operation in my array. And here the memory allocation is happening in a continuous fashion, whereas in hash map, what happening is that my hash map, you can consider it as a bucket. In the bucket, what is happening is that a new node is forming, a ball is creating, You can imagine as a new node as a ball. A ball sounds like kinda unfamiliar, but yeah. So a new node will get formed in the bucket, and if you wanna point, if you wanna access, if you wanna perform search operation, then what you have to do is that you can perform search operation based on key. You will pass key. Let's say I am passing key as India. So when I pass key India, then this key, this search operation will directly points to the India node. Now if I am giving key as US, so this key will directly points to my US node. Like this, pointing will happen. I'm not performing any searching, I'm not iterating through anything. I just have to give my key, and based on the key, it will point to its corresponding node. This is how the operation, because of this forming of node in the bucket in the hash map, that is why, because of this concept, all the insertion, deletion and searching operation will take constant time. That is why we consider HashMap as a efficient data structure. So I hope you have understood. So HashMap is used to store a table form data. To store a key value pair data in the table form, we use the concept of HashMap. And one more thing is that HashMap is a very efficient data structure. The operation, whatever the operation you want to perform, it will happen on constant time, big of one time. Now the storing internally, what will happen is that it will create a new node in a bucket of HashMap. It will keep on creating new node. We will talk about how a HashMap is implemented, but if you want to visualize the diagram which I have shown. In the bucket, India node will form, after China node will form, after US node will get formed, after UK node will form. Like this, in my hash map, the whole buckets, in the bucket, the nodes will get formed, and if I wanna search, then all I have to do is pass key name, and this key name will point to this node. So that's all. I'm not performing any iterative step. That is why the time complexity is big of 1. So I hope you have understood the overall concept. Now let us talk about how we gonna implement our hash map in our code. So let me remove all the ink here. So talking about the implementation, what I will do is that first of all I will import my package. So import java package java.util.star. After importing, what this line will do is that it will import all the packages, whatever the packages I'm having in my Java collection framework, it will import all of that. Now in the main program, what I will do is that I will write HashMap and I will give key data type. Let's say that I'm giving key data. If I'm storing country name and value, then key data will become string. If I'm storing an integer, then key data will become integer, right? So key data type, comma, value data type, what value I'm storing and what is its data type. So value data type, again angular bracket close, after my hash map name, let's say my hash map name is hm, is equals to new hash map. Like this, I will create my hash map in my Java program. Now let us talk about the operations involved in it. If you recall, linked list, we have operation like insertion, deletion, insertion at middle. If you recall the concept of heap, we have the insertion deletion operation. Similarly, in hash map, we have operation. If I want to add, then I will write put and I will pass my key and value, and the adding operation is big of 1. All you need to remember is that hash map is a very efficient data structure and the time complexity for performing all the operation will take big of 1. Because of this efficiency, most of the times we use the concept of hash map. Okay, now if I want to get a particular element in my hash map, then I will write get and I need to pass my key, and by passing key I will get my value. In that particular key value pair, what is the value I'm storing, I will get my value. And if I want to check whether this particular element exists in my hash map or not, so in order to check that, I use a function called as contains key, and this method will return me either true or false. If the key exists, then it will return true. If the key doesn't exist, it will return false. Okay, now if I want to remove a particular element completely from my hash map, then I will use the remove method. So these are the 4 different methods, and they are also methods as is empty, is full, like this is. And to calculate the size, I will write hm dot size. So this will return the size of my hash map. So this is how we will perform operations in my hash map. Now let us code the overall code of our hash map. Now first of all, what I am gonna do is that I will create I'm gonna import java.util.star. Now after that I will create my class, public class. My hash map is my class name, my hash map, my hash, here I need to give hash map. This is my class name, public class hash map. Here I'm gonna create my public main function. So here let me give my main function, public static void main. Here I need to give void main. Here I need to give string args. Now in the main program, to implement hash map, first of all I am gonna write hash map, and let's say that I am storing country values after their population. So the key value which I am storing is a string. So for that, first of all I will give string, because I am storing countries, comma integer. In the values I am storing integer value. So here I will give integer. Now my hash map name, hm is equals to new hash map. Like this I will create my hash map in my program, Java program. Now here I need to add my elements in my hash map. So in order to add, what function I have to use? I have to use put function. So I will write hm.put, and here let me pass India, and India population as 150, right? 150. Now let me again, I want to add US, so I will add hm.put, and let me give US and their population as 200. 200. Okay. Now after hm.put I want to add China, so hm.put, and here let me give China and their population as 500. Okay. Now I have added elements into my hash map. Now I wanna print it. So how I'm gonna print it? I'm gonna print it by just writing system.out.print hm, that's all. So like this I will print mine. Now if I run the code, let us see what output we'll get. So I'm running the code. So you can see that I got the output. China is equals to 50, US is equals to 200, and India is equals to 150. Now can you observe one thing, that is, first of all, initially I have stored India, after it US, after it China. Now if you observe the output, I am getting output randomly because my hash map stores data in an unstructured format. It doesn't follow a format. It doesn't store data in a structured format. My hash map is an unordered data structure. It will store the data, whatever the data you are passing in, it will store randomly. Right, you need to remember that it doesn't store the data in a structured, oh, he has given me this input, so I will store this first. It doesn't follow this fashion. It will store the whatever the data you're forming, whatever the data you are inserting, based on the internal hashing. I will talk about how hashing is happening, but based on the internal hashing, how the hashing function works, it will store the randomly. It will store whatever the data you're passing randomly. Okay. Now if I wanna delete a particular element in my hash map, then what I will do is that I will write hm.remove, and I want to pass a key. I want to delete China, so I will write China. Now after deleting this particular element, then I am printing my element. Now let us save and print it. So you can see that first of all I have printed my whole element, China, USA, India. Now after that I have deleted the whole element key value pair which is having the value China. So you can see that here the key is China. So the key which is having China as the input, I am deleting that particular key value pair from my hash map. Now after deleting the China key value pair, this is the remaining hash map. Now if I wanna add a new element, then what I will do is that I will write hm.put. I will write the same thing, hm.put, and I will write Korea, and let me give the Korea population as 50. Right, like this I will add. Now if I wanna get a particular element, value into my from my hash map as my output screen, then what I will do is that I will write hm.get, and here let's say I wanna know what is the population of India. So I will write here India, and after that I will print it also. Whatever the value returned, my get function returned, I am printing it. Okay, now if I save this and run this program, so you can see that first of all I am getting the China value. After that I am deleting China. Now it is showing null, but here I am having India. Now check your spelling, what key you have passed. You can see that I have passed some wrong spelling. Okay, so I need to pass India with the correct spelling. Okay, now let me save and run this again. So you can see that I got the output India population as 150. Like this I can get a particular key value in my hash map by just passing hm.get, and I will pass my key value, and for that particular key what is the value related to it, I will get that value as my output. Okay, now if I wanna check whether the key exists or not, so let me delete it and let me comment all these things. Okay, now I wanna check whether a particular key exists in my hash map or not. Then what I will do is that hm.key contains key. So this contains key will give me whether the key exists or not. Here I am passing India. Now I know that India exists in my hash map. So if India exists, then it will return me true. If India does not exist, then it will return me false. So first of all let me print the hash map, and after that I will see whether it is existing or not. So you can see here, let me print it also. System.out.print. Okay, now you can see that here in the hash map my India key is existing. So if India is existing, then it should return me true. So you can see that I got the output as true. Now if I pass some random country name as India, or as let me give Jabir as a country name. Now let me save and run. So if I run this, then I should get false. You can see that I am getting false because Jabir doesn't exist in my hash map. Like this I will check whether the key exists or not. How I can add? By using put function. To get a particular element I use get function. To remove a particular key I will use remove, and I will pass key. Now if I wanna check whether the given hash map is empty or not, then I will use is empty. And to get a particular size of a hash map, then I will use size function. Right, this is how we will perform and create hash map in my Java program. I hope you have understood how we implement Java in my hash map using Java collection framework. Now let us talk about another concept. Now let us talk about how we can iterate on a particular hash map. Now to iterate, let's say that I am having hash map as, let's say this is my hash map. In this I am storing India. India population is 100. After China population is 200, and US population is 50. Like this I am storing nodes in my hash map. Now I wanna iterate through each and every node, and I wanna print the key and the value related to that particular hash map. Now how I can do that? I can do iterative process by writing this single line. I need to write this line. After that I will run a loop for this key. So what I am writing is that I am creating a set. We will talk about sets in later chapter. In few minutes we will talk about sets, but first of all I need to write set. After that what key data type I am using. In here you can see that my key data type is string. So if my key data type is string, then I will write string here. If they are integers, then I will write integers. After that I will write my set value is equals to my hash map. Let's set my hash map name is hm. So hm.keySet. So what this function will give is that it will return whatever the keys I am having in my hash map. Here the key I am having is India. After that I am having China. After that I am having US. Right, in the hash map this will hm.keySet will return me this, and I know that if I know the key, then I can easily iterate their values. Right, for a particular hash map, let's say there is element and I know the key value of it. If I know the key, what is the key, then I can go to its value, because to get a particular element I need to pass key. So hm.getKey, and here I will pass whatever the keys I am having. I will pass and after passing I will print it. Like this I will iterate. So what I am doing is that I am creating a set, and whatever in the hash map, whatever the keys I am having, I am storing those keys into a set. After that I will run a loop, and I will run a special type of loop. So the special type of loop which I'm gonna run is, I'm gonna run for each loop. And I believe that this is the first time you guys are hearing this, for each loop. So for each loop is very similar to our general loop, but the only difference is to iterate on objects, to iterate on collection of items, we use for each loop. To iterate data types we use general loop, but to iterate collections, to iterate items in different collections, we use for each loop. I will show you how for each loop works. So by performing for each loop, we will iterate the whole hash map. And again, iteration process is also big of one time. It doesn't take big of n time, even though we are running a loop, but the loop which we are running is different, and the overall there is a structural difference. So all you basically is doing is that you are just passing key, and this key will point to this, and China this will point to this, and this US will point to this. Like this, you are basically taking the key set, and after taking the key set, if you know the key for a particular element, then you can access directly its value, so you are not performing any operations there. So this is why the whole operation will take big of n time. Now let us code this thing. So let me comment this out. Now what I'm gonna do is that first of all I will create a set of, let's say that I'm storing keys, right? So here I will pass string, data type string is equals to keys is equals to hm dot get key set. Here I need to write key set, I need to get the key set, so I will write get key set. Now after that I need to run my for each loop. So to implement for each loop, all I have to do is first of all I will write for each. Now you will get this option. So here it is showing string. After that let me write this string is iterator. Here if you imagine the general loop, I need to write k. For example, for in this I need to give initialization, int I is equals to 1. After that I will run a loop. Similarly, I is a initial what you can say, a variable which is used for in order to run the loop, we are using that variable. Similarly, here in the for each loop we will write the string name. After that k, this will become my iterator variable. Okay, and for k in keys, whatever the keys I am getting, I will print system.out.print. I will print the key value. So first of all I will print hm.get. Here I will pass my key value plus give a space like this, and hm, first of all I will print the k value, whatever the key I am having, I will print k of, that is nothing but my key, after its value. So I will write hm.get my particular key. Like this I will print. Now after this let me give a next line. Here system.out.print like this. Now if I run this, then I will get first of all India, its value, US value, China value. Now let me save and run. So this is my hash map, and if you run a loop, then you will get the output like this. First of all China, key and its value, after key and its value. Like this we will use for each loop, and here you need to remember that the time complexity for this will be big of 1. Okay, now this is how we perform iterative operations. Now let us talk about some more concepts. Now let us talk about what is the implementation of HashMap. What is happening internally in my Java program when a HashMap is created. So to understand the internal implementation of HashMap, let us take a HashMap as an example. Let's say I am taking HashMap as this one as an example. Here on the key side I am storing countries India, and on the value side I am storing their population. For example 100, China 200, right? After that US 50, UK 30, after Nepal 20. So here I have demonstrated, I have shown you in normal form how a hash map will look like. Now internally what will happen is that HashMap is implemented on a concept, and the name of that concept is arrays of linked list. So a HashMap is implemented on the concept of arrays of linked list. So what is the meaning of it? So we know arrays, we know linked list. In arrays we have seen many a times that in arrays at each and every index we store some data type, we store some primitive data type. Generally we have seen that we used linked list, we used integer, we stored boolean type, float, all these different data types we have stored in our arrays or array list. Now we already know a linked list. So a linked list is a chain structure in which it will have a node, and this node will point to next node, and this pointing will continue until I get the end of my chain, that is my null node. So these two are different data structures. Now the implementation of HashMap will happen by combining these two data structures. So internally what will happen is that my Java compiler will create an array, and in the place of each index it will store a linked list. It will store a linked list. So what will happen is that, let's say this is the array I am having. Let's say the size of the array is 0, 1, 2, 3, 4. Right? I am creating 5 elements. Okay. Now what will happen internally is that at each and every location, at each and every index, it will, instead of storing a primitive data type, it will store a linked list. Let's say this linked list 1, linked list 2, linked list 3, linked list 4, linked list 5. Like this it will store separate linked list. And again, linked list is a chain data structure, right? So linked list will point to this. Here it will create a node. Let's say India is a node, and India population is 100, and India is pointing to US population is 50, right? Similarly, randomly it will create some random elements, and it will start storing the linked list in it. Okay, so my compiler will create randomly, and it will start storing. So here I am having China population is 200. Similarly, here I am having Nepal value is 20, and it is pointing to UK value is 30. Like this it will store. At each and every index I store a linked list, and a linked list is again a chain structure, right? So this will point to separate nodes in itself. Okay, now this is the actual visualization of a hash map. You can see that I have created an array, and at each and every index I am storing an element which is a linked list, and this linked list will point to the next node. Like this we create a chain structure in my whole array, and this structure is the internal implementation of HashMap. This is how the HashMap will get implemented in my compiler. Now let us talk about the operation. What will happen if I want to add a new element, if I want to get a new element, if I want to remove a new element, what will happen in this whole structure? So let us talk about put. So if I want to add a new element, a new key value pair in my given hash map, in my existing hash map, let's say that I am passing Canada, and the Canada value is, let's say that Canada value is 50. Okay, now I want to add this. I want to add this new key value pair into my hash map. Now what I will do is that I will check whether that particular element, whether that key value pair exists in my hash map or not. So I will get two steps here. I will get two directions. That is, the first step is if already exists. If already exists, then I will do something else. If it doesn't exist, then I will add it. Then I will add that particular node into my array list, into my linked list. Okay, this is what I'm gonna do. Now to check whether the given key value pair exists in my hash map or not, I use the concept of hashing. So I have said you that hashing is used to convert one data type into another data type. We use the concept of hashing, and this can be done using a function. The function name is hash function. So what hash function here will do is that hash function is like a black magic box. It will take some input and it will give me some output. This is the basic working of a function. So it will take some input and my function should return me some output. So this hash function will take key value as the input, and it will return the bucket index, at what bucket it exists. If it exists, then we will change the value. If it doesn't exist, then we will add that particular key value into my hash map. So it will return the bucket index. So what is the meaning of this bucket index? Generally the terminology is, in place of using arrays, we call this array as a bucket. And this hash function in Java we call this hash function as hash code. So this hash code will take key value as my parameter, and it will give output as my bucket index. So when it gives me a bucket index, I will go to that particular bucket. Let's say that it has given me bucket index as 2. So what I will do is that I will go to that particular index. So I will come here. I will come in that index because the index is 2. Now I will check in the linked list for the 2 element, for the 2 index, I am having a linked list. So in that particular linked list, I will check whether that particular key value pair exists or not. So I will iterate through each and every node of the index, through each and every node of that linked list. After iterating, if it doesn't exist, then what I will do is that I will add that. So you can see that in the linked list 3, I am having only one node, and that node is China. So if it doesn't exist, then I will add the new node, that is Canada, and the value is 50. So I will add like this. So first of all, the first step is call my hash code, and hash code will give me my bucket index, and at that bucket index iterate whatever the linked list we are having. At that bucket index, at the 2, we are having a linked list as 3. So iterate that particular linked list, and in the linked list, if it exists, let's say I am adding China, and I want to change the value of China. So what I will do is that I will write 250 here. So you can see that on the index 2 in the linked list 3, my value is already existing, China is already existing. So what I will do is that I will change the value. I will change from 200 to I will make it 250. Like this I will change it. So if it exists, then change the value, that's all. If it doesn't exist, then basically add. I will iterate. After it, I will iterate each and every node. After it, I will add that into my linked list. So this will be my whole process of adding. Now if I want to check, I will do the same thing. I will call my hash code. It will give me some value, bucket index, and I will go to that bucket index in the linked list. I will iterate and I will check whether my key exists or not. If it exists, then I will remove it. This is how I will perform remove operation. Similarly, the key contains key operation is also same. So what I am basically doing is that I have understood the structure, the internal implementation structure of my hash map. So the internal implementation structure is, it will store the array of linked list. Internally, this is what happening. So first of all, first step will be, I will call my hash code. My hash code will return me bucket index. Bucket index is nothing but in the array a particular element index. So I will go to that particular element index, and I know that in that particular element I am storing linked list. So in that linked list I will search for all the nodes this linked list having. If it exists, if any of the node which I am going to insert, if it exists, then I will basically change the value. If it doesn't exist, then you can add. This is how the internal implementation works. I hope you have understood. Now you might ask one thing, oh Jabir, okay, the hash code, one thing you need to keep in mind, that hashing is a very efficient thing. It will take big of n one time. So this will, the first step will take big of one time. Now you might ask that Jabir, we are iterating in a linked list. After going to a particular element index, here at that particular index, basically I am storing a linked list, and if I wanna iterate n elements in my linked list, then the time complexity will become big of n, because I know that the linked list iteration, the time complexity to iterate all the elements in my linked list will become big of n. So how you can tell me that the time complexity will become big of n? Because I have said you that all the operations that we are gonna perform in the linked list will take big of 1 time. Now if we are iterating through each and every node of my linked list, then it will take big of n time. So to understand that concept, we need to understand one new concept, and the concept is lambda function. So some people call it lambda parameter, I am calling it lambda function, some other programmer will also call some other thing. But based on the concept of lambda function, this iterative process will also give me big of 1 time. Now what is this lambda function? So to understand the concept of lambda, let us take the array which we have taken the example. Let's say that the elements which we are having are in the array 2, 3, 4 elements. Okay. Now this is storing separate linked list. Here let's say I am storing India, it is having 100. After this is storing US is having 50. Now this is having China is having 250, and this is pointing to Canada, and Canada is having 50, and Nepal 30, and this is pointing to UK 50. Like this I am having my arrays of linked list. Okay, I am having buckets, different buckets. Now what the lambda concept says is that lambda is a basically, you can say, call it as a variable, and the formula of lambda is equals to small n divided by capital N. Now what are this small n and capital N? Small n represents the total number of nodes, the total number of nodes in my whole linked list structure. So the total number of nodes, here the total number of nodes is 1, 2, 3, 4, 5, 6. Here the total number of nodes will be 6. Okay. After that, capital N represents the total number of elements in my array. Or you can say total number of buckets. This singular element, we consider that single element as a bucket. Okay. So the total number of buckets or total number of elements present in my array, that thing will become my capital N. Now based on the value that this will give me, here you can see capital N value is 4. So this will give me 6 divided by 4. So this will give me 2 2 ja, 2 3 ja, this will give me around 1.5. Okay, so the lambda value is 1.5. Now in hashing concept, we have a parameter called as k, and the k value should always be greater than or equals to lambda. So the lambda should always be less than or equals to this. If this is a condition, then this is a condition of good hash map. This is a condition of good hash map. If I am crossing this condition, for example, k, if I am violating this condition, my lambda is going beyond k value. And one more thing is that we call k as threshold value. I am going into some theoretical stuff here, but we call the k value as threshold value. Now for example, let us consider the k value, the threshold value as 2. Okay. Now here the condition is satisfying, 1.5 is less than or equals to 2. Okay, if this condition is satisfying, then the given hash map is a good structured format hash map. Okay, good. If I am getting this condition, then it is given that iteration will take a constant time. So I don't need to worry about the time complexity of iteration. Okay. Now up to now I hope you are clear. Now the question comes along that what if the lambda value exists the k value? Here you can see that if you observe the formula, lambda is directly proportional to number of nodes. If the number of nodes are increasing, then lambda value will also increase. Let's say that for some n value, my lambda has become 2.1. Now it is no longer following the condition. If it is not following the threshold value condition, then what happens is that we will perform a new thing. That new thing is called as rehashing. If this condition is not satisfying, then If it is not satisfying, then it is a bad hash map. If it is a bad hash map, then we will perform rehashing. So in rehashing, what we will do is that you can see that lambda is inversely proportional to 1 by n. So if I am getting a condition where my lambda value is increasing and violating the property of my threshold value, it is increasing the value of threshold value, then immediately I will perform rehashing, and rehashing will increase the size of my array. It will multiply and it will do 2x size of my array. So rehashing will increase the n value, n is equals to 2 into n. So I will create an array of 8. 0, 1, 2, 3, 4, 5, 6, 7. So immediately I will increase the size of the given array, and after that I will reshuffle the nodes. I will not form long chains. I will avoid formation of long chain for a single element. Whenever I am getting this long chain, I will check the lambda value and the k value. If k value is not greater than lambda value, then I will immediately perform rehashing. And what rehashing will do is that it will increase the size, and after increasing the size of array, it will reshuffle the nodes. It will reshuffle the nodes and it will break this long chaining process. So India will come here, after that US will come here, after that China will come here, after that Canada will come here, similarly Nepal will come here, UK will come here. It will not make long chains. Whenever I am getting long chains, I will check my lambda condition. If I am violating my lambda condition threshold value, then I will immediately call rehash function. After calling rehash function, I will expand my array size. This is what will happen. And because of this rehashing concept, my total operations, like overall operations time complexity, will be big of 1. I hope you have understood. This is what will go internally. This is what will happen. This is the implementation of my hash map. I hope you have understood the implementation. Now I will show you the code and I will explain each and every nuance of the code. Okay, now let us talk about the code of this implementation. Okay, so talking about the implementation code, first of all, I know that I am gonna create an array, and in the array, at each and every element, I am gonna store a linked list. So what is a linked list? A linked list is nothing but chain of nodes. So to create this node, a single node, I have created class node, and this node can be of any data type. Here I can store a string. Let's say my key value is string or int or boolean. My key value can be anything, and my actual value data type also can be anything. So because I'm getting any data type, I have created a generic class. So what I mean by generic class is that I can create any data type value. So I have created a generic function, and in the node class I'm creating a constructor and I'm initializing the key and value pair. Okay, this is what I'm doing whenever I'm creating a new node. Now to implement HashMap, I have created a public class myMap, and here again same generic function. I'm using generic templates because the data type of key and the data type of value can be anything. So to handle any data type, I'm using this generic function. Okay, now in the function, what I'm doing is, first of all, I'm creating the capacity of my overall array, right? Now after it, I'm creating a linked list of buckets. I'm creating an array, and at each and every index I'm storing a linked list. So I'm making this too private because I don't want any user to access from my main program. Whenever this class is called, this class internal function will take care of these two things. Okay, that is why I have made this private. Now here you can see that I have write this super warning message. So this is basically, you can ignore it. This super warning message will check if there is any warning, then it will not interrupt the execution of my program. That is why I have written this super warning. So it will ignore, if there are any potential warnings, it will ignore it. Okay, now I am creating a constructor my HashMap. My class name is my HashMap, right? So I am creating a constructor my HashMap. In that I am initializing my bucket array. I have created my bucket array, right? So I am gonna initialize it using my constructor. Now After that I have created int get bucket index. So what this get bucket index will do is that I have told you that first of all, to add a new element I need to take a particular index, and at that index I am gonna add my new node, right? In my linked list, this is the index of my bucket, and underneath I am having my linked list. So when I am adding a new node will come add in this chain. Okay, so to get this linked list index, to get this array index, to get this bucket index, I am using hash code. This is what I am doing. So here I am calculating the index using hash code. Okay, and whatever the value get bucket index will return me, I am returning it as my function return type. Okay, now after that I am creating put function. So in the put function, first of all I am calculating the bucket index, and after calculating the bucket index I need to iterate, and after iterating I am going to check whether this particular node exists or not. If it exists, then I will add it. If it doesn't exist, then I will change. If it exists, then I will change the value of key, right? I will basically change the value, right? Previous value to new value. If it doesn't exist, then at last I will add it. At last I will add the node in my data type if it doesn't exist. Okay, this is what I'm doing. First of all, I'm checking whether my key exists or not. If it doesn't exist, then I'm adding. If it exists, basically I'm updating the value. That's all. Okay, this is what going on in my put function. Now let us talk about the get function. So first of all, I'm taking the key, what is the bucket value for that particular key. After getting the bucket value, I am performing a loop to get that particular node, to get that particular key value pair. I am performing loop and I am searching for that particular element. If that particular element exists, then I am returning its value. If it doesn't exist, then I am returning null. Okay, this is get function. Now let us talk about remove function. So in remove function, first of all, this is very same to get function. So first of all I am getting that particular key bucket value. After getting the bucket value, I am running a loop, and in that I am searching at what node that key value is existing. If it is existing, then I will remove that particular node from my linked list. Okay, and after that I will come out of my loop. This is what I am doing. And if that particular node doesn't exist, then I will return null. Okay, now in the main program, what I am doing is that I am creating a hash map of string and integer data type. Okay, now I am calling my function put function. In that I am adding 1 as my character, after that my 1 as my integer. Like this I am adding. After that I am using get function, and after that I am removing a particular element in my hash map. Like this I am doing. Now this is the overall code of my hash map, and I hope you have understood the overall implementation, overall operations that goes beyond on it. Now in the part 2, I hope the overall lecture is 1 hour. I don't want to drag it. So in the part 2 we will solve some questions based on hash map. After that we will move further into linked map, tree map, different data structures. So with that being said, I will see you in hashing part 2.